right, everyone has their formula sheet out? Where's your formula sheet, Grady? Don't steal it, I need it back. All right. So the normal distribution, we are looking at the normal curve, okay? We know that total area under the curve is 1, okay? If we are going to be able to estimate probabilities, the probability is like the area under the curve. So if I wanted the probability of being less than your mean, we know we talked about yesterday the mean being the middle. So if I were just looking at it that way, the probability being less than that would be what? Yep, it's probability of our mean being less than our mean. Since it's symmetric, it would have to be 50%, right? Well, the problem is, if everything looks like a normal curve, the probability should be the same every time, right? We know 50% above, 50% below. We know that like 68% is within 1 standard deviation and so forth from the empirical rule. But we have to be able to take everything and put it in terms of a common unit. And we did that at the beginning. Remember, we had like a scenario, I'm like, okay, you took a math test and you got a 95 on it and the standard deviation was 10. And you took a history test and got a 96, but the standard deviation was 4. On which test did you do better? And what did we calculate? Z-scores. So the Z-score allows us to take different sets of data and get a Z value. Z is how many standard deviations you are from the mean. So equal to the mean would be a standard deviation. How many standard deviations away? If you're equal to it, it's 0. Okay, if you make it here, you're 1 standard deviation above. Here would be 1 standard deviation below, and so forth. So what we're going to do is take whatever data we have, compute the Z-score so that we can use the regular normal curve to calculate probabilities. And we will have a table that can calculate that for us. So, I'm just going to make a note here. We can take any normal distribution calculate the Z-score and use a probability table to get these probabilities. If you look on your formula sheet, it's like the 3rd piece of paper, table 5. It is our standard normal distribution. You see at the top it has that bell curve. This has all of our probabilities calculated once we get a Z-score. So once we have a Z-score, we can just go to this table and calculate the probability. On the table, it gives the area for values to the left. So if you look at the top of the table, it even has a picture that tells you that. I'll mark a Z, and the number in the table is the probability to the left, the probability being smaller than that value. What would we do to get a probability to the right? 1 minus. So if you need to be larger than something, you just do 1 minus. If you want to be less than, that's what the table gives us. Okay, and if you ever forget that, looking at your formula sheet, it has that picture at the top and tells you. So, example 1. IQ scores can be modeled by a normal distribution. So I have to know it's normal so that I can use table 5. The mean is 100, standard deviation is 15. Find the area to the left of a score of 120. What do I have to find first? Z-score. Remember, Z is your value minus the mean divided by standard deviation. Our value is what?
120.
Minus the mean of 100 divided by 15. And we get? I am going to draw a picture today just to illustrate what we're doing. I want the area to the left. I'm asking you, what's the probability that you are smaller than a z-value of 1.33? Area to the left is what our table gives us. So we are going to go to the table. Now, it takes a little bit to get used to. Down the left-hand column, you've got the z-values. You need to go down to the 1.3 row. And then across the top, they have the second decimal, so like 0.00, 0.01, 0.02, 0.03. So you want the 1.33 row and the 0.03. So 1.3 row, the 0.03 for the second decimal. Everybody look at this table and make sure you can find that. If it helps you, you can use another sheet of paper to kind of cover up and help line up your row. What is our value?
0.9082.
All right, I want everybody to be looking at a formula sheet. Today's lesson makes no sense if you don't have a formula sheet to look at. Is that okay with everyone? So if I went the area to the right, the probability of being above this value, what would you do? And we get
So if it was to the left, did you say you would add one?
no,
Or would it?
to the left is what it gives us. Actually, my picture is not drawn very accurately because the center would be at 0, wouldn't it? So if my z is positive 1.3, it would be up here. So the table gives you area to the left. That's what the number is. So if I want area to the right, you just subtract 1. Other questions? Look at this one. Find the area under the standard normal curve to the left of z equals negative 0.38. Picture is not required, but can be helpful. This is like 0, negative 0.38. So that means you are 0.38 standard deviations below. If I want area to the left, then I am just looking up from the table. So I go to my z, down to row negative 0.3, and over to column 8. And we get
Where's that at on the table? So why do you go here and since it's like 0.38?
the 8 is the second decimal place is
Oh,
across the
okay.
top. Other questions? So if I want the area under the curve to the right of 1.25, so that's 1.25 standard deviations above the mean, and I want to be to the right of it. How do we do to the right? And then I look up when my z is 1.25. We get so 1 minus 0.8944. We get 0.1056. See. Find the area under the standard normal curve between a z of negative 1.02, so that's below the mean, and a z of 2.94. How would I get just between those two values?
The probability.
You could find out.
The probability.
Yes. If you look up the probability of 2.94, and then look up the 1.02 and subtract them, you'll get the difference. So I look up when my z is 2.94, and that is, and when my z is negative 1.02, and if I subtract those, we get 0.8445. D. Find the area under the standard normal curve to the left of z equals negative 1.32. So that's below the mean. I want to be to the left of that. And to the right of 1.97, so that's above the mean. I want to be to the right of that. How would I find the area to the left of negative 1.32? Look it up. Negative 1.32 is, okay, to the right of 1.97. If I look up 1.97, it gives me to the left. How do I get to the right? Okay, so I have to do 1 minus 1.97 is, and I want the total area, so I'm just adding those two things together. So what does that give us? Is this okay? A pediatrician finds the heights of her female 3-year-old patients are normally distributed with a mean of 38.72 inches. That's my mean. Standard deviation is 3.17. Find the proportion of 3-year-old females with a height of less than 35 inches. So I'm asking you to find the probability that a given person has a height less than 35. What do I have to do though?
35 goes on the
We have to convert it into the z-score so that we can look it up on the table. So z is our value minus the mean divided by standard deviation. By the way, I'm still missing a calculator, so please check if you left with that. Okay, z-scores, we go to 2 decimal places because that's all the table gives us. So that's negative 1.17. So I'm just asking to find the probability that z is less than negative 1.17. Okay, you can draw a table, or draw a picture, I mean, if it helps. Less than is what we need. So we just look up from the table. Negative 1.17 gives us find the probability a randomly selected 3-year-old girl is between 35 and 40 inches tall. What do I have to do? I'm asking you to find the probability that x is between 35 and 40. So I need the z's for both of those. I already know this one is negative 1.17. So I need my 40 for the z, or my z for the 40. So 40 minus the mean divided by standard deviation. So I'm asking you to find the probability. Z is between a negative 1.17 and a positive 0.4. How do you find the probability being between those two? You subtract the two. So we have to look up the bigger one first. So when our z is 0.40, that is minus, when I look up negative 1.17, that's 0.1210. So if I subtract those, we get so there's a 53.44% chance that her patient is between 35 and 40 inches tall. So key here, you have to find the z's and then look up on the table. If you want area to the left, you just look it up on the table. Area to the right is 1 minus, between, bigger one minus smaller one. And you know you have to get something between 0 and 1 every time. So if you flip them, you would get a negative and you could catch it. Yeah.
How can we use like the negative 1.17 from the last one if it says 35 inches, like with a height less than 35 inches, and then this one is just 35?
I didn't use the probability, I just used the z value. So what I would get if I converted 35 into a z. Good point. Any other questions there? Okay. I want you guys to take this question and read it and see if you can figure out what you might get. Right. I'm giving you the answer. I'm saying the area to the left is 0.1. If you draw a picture, it's saying this shaded area is 0.1. You have to find out what z is. So, our table gives us area to the left, right? We are looking inside this table for the closest we can get to 0.1. So, I see yeah, do you guys find a 0.1003 inside your table? And the z that matches that is 1.28. So that is the answer. We found the z-score. When the z is negative 1.28, you have 10% to the left. B, the area to the right is 0.25. So this area is 0.25. I need this z value. Now my table doesn't give me area to the right. If the area to the right is 0.25, what's this area? That's what you need to look up in the table. So I'm trying to find the closest I can get to 0.75 in this table. I have a 0.7486 and a 0.7517. So it'd be about in the middle of those, wouldn't they? So that is 0.6, in between 6.7 and 6.8, could I say 6.75? It's kind of in between those two, the closest we can approximate.
What are those between?
So we're looking for 0.75, and the closest we can get is in between those.
Oh, I thought I was looking at
Oh,
7 and 5.
Yeah, it's because this time we're given the area, so it falls in between those, so I did 0.675.
Where'd you get the 5 from?
I just estimated, like, if you add those up and divide by 2. Other questions? You guys understand how we're finding these in the table?
How do you feel confident that you're found the smallest, well, the closest?
You just look at the numbers on either side and just make sure it's, so, do we know it's not really 0.674? No, we're just getting as close as we can from our table. Okay, the middle 99% of the distribution is between these scores. So I'm saying 99% is here in the middle. That gives me 1% left for each end, right? So if I split that 1% in half, that means I would have 0.005 over here to the left. Look in your table. We need both of these Z's. Look for as close as we can get to 0.005. So we have 0.0051 and 0.0049. So just in the middle of those. So that is negative 2.575. So what do you think this one would be?
Positive 2.575.
Because it's symmetric, we know it's the same on each side. So it's just between negative 2.575. I'm positive 2.575. Because we already know the normal curve is symmetric, so if there's a 0.5% on this side, 0.5% on that side, the z's are the same, just one's positive and one's negative. I want you guys to see if you can set this one up. Take a second and read it. See if you can our mean, and then the standard deviation. What am I asking you to find? I'm asking for their score. If they're at the 85th percentile, it's been a while, but we've talked about percentiles. What does that mean? So it's saying 85% of the scores are less than or equal to theirs. So this probability is 0.85. Can you find the z so that 85% is less than or equal to that? So I'm going to my table. I know my probability, so I know the number inside the table is 0.85. What's the closest I can get? So we agree 1.04 is closest. So that's the z value. Now I want their score. So think backwards. Z is x minus the mean divided by the standard deviation. I know the z is 1.04. X is their score, which I don't know. The mean was 1,049. Divided by the standard deviation, 189. So if I solve that, multiply over my 189. over my 1049. So they had about 1,246 if you rounded to the nearest whole number. So it's not that the math is all that hard, but I could ask a lot of different things with these questions. I can ask you to find a probability, I could ask you to find the z, I could ask you to find the original x value. So we just have to think very carefully about what we're being asked to find in each question. All right. It is well known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters, standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the lengths of rods that make up the middle 90% of all steel rods manufactured. Okay, so we only want to accept 90%, so that means we want to get rid of the shortest and the longest ones, right? We want to keep the best 90%, so the middle 90%. So the area in the middle is 0.9. That means I have 10% that I'm going to throw out. How much on each end? So this would have to be 0.05. Can you find the z that matches 0.05?
Negative 3.3. Oh no, that's 2.
Negative 1 point.
Or 645.
Yeah, negative 1.64 and 6.65 are the same distance apart, so negative 1.645. So what would be the z for the upper? The positive. Okay, so I know my two z values. But what did I ask you to find? I want the actual lengths. So for each of those, we know z is x minus the mean divided by standard deviation. So when my z is negative 1.645, we don't know x, the mean is 100, divided by 0.45. Let's just go to 2 decimal places. So for that one, I got 99.26. When I do the upper, so we want to know the lengths that make up the middle 90%, so anything between 99.26, what are my units, do I know, centimeters? And 100.74 centimeters. So you would keep anything between those two measurements. If it's smaller than the 99.26 or bigger than the 100.74, you would throw it out. All right, can you bear with me for 2 more slides and then I'm stopping. The last new piece, and I don't know why, but this is just a notation. When you see a z with a subscore like z of 0.1, that means 10% is to the right. I don't know why that's to the right and not to the left like our table is, that's just what they do. Okay, so anytime you see a Z with a little subscore, that's telling you the area to the right of that value. And we know if we want area to the right on our table, we have to do 1 minus the number on our table. So let's work one of those. If I want you to find Z of 0.1, that means the area to the right is 10%. So this is 0.1. So what's this area over here? So you have to find the Z when the area is 0.9. So you go to your table, you look up 0.9, as close as we can get. What is the closest? 'Cause that's 0.8997. I want you guys to try Z of 0.65. This means 0.65, that means 65% of the area is to the right of this Z value. So we need to find our Z to make this true. If 65% is to the right, how much is to the left? So I'm going to my table, I'm looking for 0.35, as close as we can get, and that is 0.3483 is the closest it gives me. So negative 0.39. If you said negative 0.385, that's also fine. All right, are we doing okay? It's a little bit different just trying to figure out, am I asking for a Z or am I asking for the probability? Game plan, I have one more slide of examples on here that I want to do tomorrow as a refresher when we come in. So you have about 10 minutes right now, you can start the 7.2 homework. Tomorrow we'll do that example, and if there's anything we're struggling with, I might throw up some more examples as practice, but you will have time to work on homework in class tomorrow. So the packet is due Monday.